Once we have set up our hypotheses, we need a way to measure the evidence against the null hypothesis. We do this using a test statistic, which is a numerical summary that tells us how far our sample data are from what we would expect if the null hypothesis were true. A test statistic is simply a number computed from the sample. It measures how much the data deviate from the null hypothesis. For example, it might measure how far a sample mean is from a hypothesized value, taking variability into account. From the test statistic, we compute the p-value. The p-value is the probability of observing a result at least as extreme as the one we obtained, assuming that the null hypothesis is true. To interpret the p-value, we think about how surprising our data would be if the null hypothesis were true. A small p-value means the data are unlikely under the null hypothesis, while a large p-value means the data are consistent with the null hypothesis. The key idea is that smaller p-values provide stronger evidence against the null hypothesis. However, it is important to remember that the p-value is not the probability that the null hypothesis is true. It is a probability calculated assuming that the null hypothesis is true. To make a decision, we compare the p-value to the significance level, often called alpha. If the p-value is less than alpha, we reject the null hypothesis. Otherwise, we fail to reject the null hypothesis. Common choices for the significance level are 0.05, 0.01, and 0.10. The choice depends on how serious the consequences are for making errors in the specific context. Let's look at an example. Suppose we test whether a population mean equals 0 versus whether it is greater than 0, and we obtain a p-value of 0.03. This p-value means that if the true mean were 0, there is a 3% chance of observing a sample result as large or larger than what we saw. Because this is unlikely, it provides evidence against the null hypothesis. Now consider a more detailed example involving a headache medication. Historically, the average time to relief is 30 minutes. A sample of 25 patients using a new formulation has an average time of 26 minutes with some variability. We set up the hypothesis so that the null hypothesis says the mean time is 30 minutes, and the alternative says the mean time is less than 30 minutes. This reflects the idea that the new drug may work faster. After performing the test, suppose we obtain a p-value of 0.0098. We compare this to our significance level, say 0.05. Because the p-value is smaller than 0.05, we reject the null hypothesis. This gives us evidence that the mean time to relief is less than 30 minutes, suggesting the new medication works faster. Next, it is important to distinguish between statistical significance and practical significance. Statistical significance tells us whether the data provide enough evidence to reject the null hypothesis. Practical significance asks a different question. It asks whether the size of the effect is large enough to matter in the real world. A result can be statistically significant, but still too small to be meaningful. For example, with a very large sample, even a tiny difference can produce a very small p-value. On the other hand, with a small sample, a meaningful difference might not be statistically significant because there is too much variability. To evaluate practical importance, we often rely on subject matter knowledge and define what size of effect is meaningful before conducting the study. Another important tool is the confidence interval. A confidence interval provides a range of plausible values for the population parameter and helps us understand both the size of the effect and the uncertainty in our estimate. When interpreting a confidence interval, if the entire interval lies above a threshold of practical importance, we can conclude the effect is meaningful. If it crosses that threshold, the importance is uncertain. If it includes 0, The data are consistent with no effect. Consider two studies that both report an average improvement of 9 points. In the first study, the confidence interval ranges from 3 to 15 points. This means the true effect could be too small to matter. In the second study, the confidence interval ranges from 7 to 11 points. Since the entire interval is above a meaningful threshold, we conclude the effect is both statistically and practically significant. The key takeaway is that confidence intervals provide more information than a p-value alone. They show both the estimated effect size and how precise that estimate is. To recap, a test statistic measures how far the data are from the null hypothesis. The p-value tells us how unlikely the data are under the null, and the significance level determines our decision rule. Finally, remember that hypothesis testing is about evaluating evidence, not proving something is true. We should always consider both statistical significance and practical importance when interpreting results.